this class. For today, we're discussing on a very important concept called center of gravity. By definition, what's center of gravity? Center of gravity is simply a point where the mass or weight of a body is assumed to act. So center of gravity is like a point where the weight or perhaps mass of a body is assumed to act. For instance, if I have an object in this form, the center of this object, let's say from here to here, is 50, here to here is 10. Of course, half of 50 is what? 25. Then I know that my this will be 5. Here to here will be 5, 25, only 50. That's the half of this one. For this one is 10. Then we count 5, right? So this point where they meet is called the center of. Alright, so where is this object? Where the center of gravity of this object is at this point here. So it simply means that the center, or perhaps this center is simply where the weight, or perhaps the mass of this body acts. So center of gravity is like a point, this point here, where the weight of the body, or perhaps the mass of the body acts. When it comes to center of gravity, we are actually looking for two components. Component one is called the x-axis component, and component 2 is called the y-axis component. Now look at this. We have two components here. We're going to look for x-axis and component 2 for y-axis. Look at this. When it comes to center of gravity, we are actually focusing on two stuff. Number one is called for x-axis, and number 2 is called for y-axis. Now, when we say for x-axis, what do we mean? When we say for y-axis, what do we mean? We actually mean for x-axis. For x-axis, we actually mean the center of gravity along x-axis. So what's the formula guiding the center of gravity along x-axis? So the center of gravity along x-axis is going to be x bar, which is equal to the summation of x a over summation of a. This one, summation of x a becomes x1 a1 plus s2 a2 plus it continues all over a1 plus a2. So when it comes to center of gravity along x-axis, I have x bar is simply the symbol for representing center of gravity along x-axis. So in other words, this one becomes summation of xa over summation of a. And summation of xa becomes x1 a1 plus s2 a2 plus s3 a3 s4 a4. It continues that way, depending on the number of components you have. If I'm given a figure and I'm going to find the centroid of that figure, whenever I hear the word centroid, I'm actually looking for the y-axis and what the x-axis. That's like the concept. So to look for the y-axis of centroid, right? If I'm given a figure, find the centroid of the figure. I'm going to find the word center of gravity along both x-axis and y-axis of that figure. So now for x-axis here, I'm looking at x bar is equal to summation xa over summation a. Now look up. I'm giving you x1 a1, s2 a2. What of s3 a3? Listen, depending on the number of components you have. For this case here now, I'm assuming that my number of components is 2. So I have just 2 stuff here. 1, 1, 2, 2. If I'm given a figure whereby that figure has 3 components, so I will hand this one with x a2, a3, s3 all over a1, a2, a3 for 3 components. So this is like a formula for solving problem under center of gravity along x-axis. Let's discuss for other word for y-axis, please. for y-axis, when it comes to y-axis, what's the gravity along y-axis? The center of gravity along y-axis is going to be y bar is equal to summation ya over summation a. I have that y1 a1 plus y2 a2 all over a1 plus a2. So depending on the number of components you have here too, if you have 10 components, I'll have y1 a1 y2 a2 plus y3 a3 plus y4 a4. It continues to 10 components. But this is, I'm assuming I have just 2 components, so that I have it here. This is like the concept behind center of gravity. So for this concept here, I can also call center of gravity centroid, right? So if I'm given a question, find the centroid, that's all. When you have the word centroid, I'm looking for what for x-axis and y-axis components. So let's take a quick example. Alright, before the example please, I'm going to give you a table. So before the example, note the following table please. Position of centroid of plane geometric figure please. Put down. So heading from here, one line space paragraph. Position of centroids of plane geometric figure. Position of centroid of plane geometric figure. Alright, as we proceed, I have shape, I have area, I have x bar. What's x bar please? Center of gravity along x axis please. Alright, I have y bar. Y bar is what? Center of gravity along y axis. Alright, I have this table below. Now, this table is very much more important please. To find the center of gravity of, when it comes to this concept here, we are dealing with shapes. Then I gave you that position of centroids of plane geometric figure. So we are dealing with figures here. Alright, look at this. Number one, rectangle. For a rectangle, the area becomes BH. I have the center of gravity for a rectangle becomes B over 2. Here becomes H over 2. For a triangle, I have BH over 2. Next up, B over 3. Finally, H over 3. Next up, I have a circle. For circle, I have pi over 4 d squared. For the center of gravity along x-axis, I have d over 2. Y-axis, d over 2. I have semi-circle. I have that pi over 8. D squared and d over 2. Next up, d over 2. That's for semi-circle. I have quadrant. For quadrants, I have pi over 16 d squared. I have 4r over 3 pi. And finally, I have 4r over 3 pi. So, finally, let's take one last one. Let's take trapezium. For trapezium, I have a plus b. The area becomes a plus b, h over 2. As we know it, I have the center of gravity for x-axis for a trapezium becomes a squared plus b squared plus ab all over 3 into a plus b. Please note this table, please. Very important, please. Plus b all over a plus b. Next up, times perhaps x h over 3. Alright, this table actually shows the center of gravity for each figure. If I'm given a rectangular figure, the center of gravity for x-axis becomes b over 2. What's b? Is called breadth. Alright, look up. Look up. Let's define the parameter here. B is the breadth, R is the radius, right? R is the radius, D is the what there? Diameter. What did you have there? H is what there? Is height. Is the height. So I have A. What will be A? A is called smaller breadth of trapezium. Alright, so I have this, please. Where B is called the breadth, R is called the radius, D is called the diameter, H is called height. Why is A is called smaller breadth of trapezium. Let's example and let's understand all these concepts. Find the position of the centroid. Now listen, centroid means what? The center of gravity. So I'm calculating for what? For both x-axis and what? The y-axis. That's the concept. Put down. Find the position of the centroid of the figure below. Find the position of the centroid of the figure below. I have the figure. Find the position of the centroid of the figure below. Find the position of the centroid of the figure below. Find the position of the half of the centroid of the figure below. So I have this piece. I have this. Look up. Look up, look up, look up, look up. First things first, how do you solve this map? Look up. I'm going to find the center of gravity for this figure. So what do? What's the first task? Look up. The question says find the centroid. Of course, no doubt. I'm calculating for what? Both x-axis and what the y-axis. So I'm going to calculate for what? Center of gravity along x-axis and what the y-axis. Now let's have it. So when you say a question like this, what's the first task? Note. Your first task is to divide this figure into possible division. So whenever I say a question under center of gravity, what's the idea? What's the first task? First task is to what? That figure you are given. Divide it into what? The possible division. That's all. So what my possible division for this one? Of course, if I divide this one here, I can divide this. The least division I can give to this is what? Something of this nature. Right? So this is I'm having the two components. I'm having components 1 and component 2. Look up. Component 1 and what the component 2. Your first task, divide the figure into possible division. This is the least one I give this one here. Right? This is the least possible division I can give it. Just segment this one here. I have one component and two components. What's your next task? Draw the components outside. So I have this first component here. Alright, I have this first component. Draw out the component, please. I have this first one, component 1, component 2. Something of this nature, right? So look up. For component 1, I have from where to get to what? 40. Now look up. To get my entire height of this figure, and put that from here to here is 160. Now if I remove 40 from 160, all I have left 120. So my entire height here now is what then? 120 millimeter, please. Millimeter. Hang on. After dividing your figure into possible division, next task. Remember this. The section outside here. I have this and this. So for section A, I have from here to here 40. The height from here to here is obviously what then? 120. How? 160 minus 40, I will have 120. Next up, for this one now is this one. From here to here is what there? 80 millimeter. My height is what there? 40, right? I have 40 millimeter. So we said first task for a question under state of gravity. First task, divide your figure into possible division. Next task, draw out the section outside in this sense. This for 1, this for 2. Now, what do you do next? What are you going to do? Find the center of gravity along what there, both x axis and what there, y axis. So let's start with that. Calculating for center of gravity along x axis. Let's make x axis. You can start with y axis or perhaps x axis, and the case may be anyone must take correct. Alright, let's start with calculating for center of gravity along x axis. Recall that we said x bar is equal to summation xa over summation a. Look up, for this figure here, how many components are there? Just 2 components. So I'll have x1 a1 plus x2 a2 all over a1 plus a2. Why? I'm having just 2 components there. Alright, I have this now. I'm having just what? 2 components. So I have x1 a1, x2 a2, a1 a2 as this case. Let's find x1. Let's find a1. Let's find x2. Let's find a2. How? To find x1 is quite simple, and also to find a2. Alright, let's get x1 a1. Let's get x2 a2. Let's get a1 a2. What is first? Let's get x1. Let's get x2. Let's get a1. Let's get a2. I have this. Right? Look up. How do I get x1? How do I get x2? First task. Look up this. So get x1. First task. For every x1, x2. Look up this. For every x1, x2, you start by considering distance. What do I mean? Look up. Look up. For x1, look up. I'm not talking for what? That's not what? X and what the y axis. So for x axis, something of this nature. For y axis, something of this nature. Y axis, right? So this x axis. This is what the y axis of this figure. For x axis now, I'm moving this manner in this sense. I mean now, for figure 1, look. For figure 1 is for x1. I mean, for figure 1, I'm moving in this manner. Before I get to this figure 1, is there any object here? Is there any object here? No object. So no distance. I mean now, so my distance there was 0. I have the 0 distance plus, look up, first task, consider distance. X axis is this format. For section 1 here, is there distance here? To go to section 1 here, no distance. So that was 0. Now, I'm not considering for section 1. For section 1 now, what's the value from section 1? We said for a rectangular figure, look up, for x axis, to get the x, the value of the rectangular figure, I'll use what? B over 2. I'll use what then? B over 2. So what might be? What might be here? For this one, what might be? This was 40. So have 40 over 2. Next up, even what was I? 20 millimeter. Let's get A1. What's A1? That is area at section 1. What's area? For a rectangular figure, that's BH. In this case, area was less than breadth as we know it. But this is our length here now becomes height. So I have BH. What's my B? What's my H? B is 40, is what? 120. So if I multiply them, if I have 40 times, what does that mean? 48,000. I mean, next up, let's get 4,800. So look up. Let's get for S2. For S2 check. Am I considering for S2 now? Am I considering any distance here? No distance here. Nothing is here. So I have 0 distance plus. Let's get. I've got my distance with 0 because there's no object here. Before I get to this one, nothing is here. So 0 distance. Now let's not consider for section 2. Section 2 is what shape? Rectangle. For star gravity for example, I have what? B over 2. What's my B in this case? My B here becomes my breadth, which is 80. 80, I have 80. Divided by 2. I have 40 millimeter. Let's get A2. For A2, what's the right for A2? B times H. That's what? 40 times what's my H there? 80. I have 80. Please, what the value is? 8 times 40 is what then? I have 3,200. What then? Millimeter square, please. Millimeter square. Now at this point, let's try to get star gravity along x-axis. So we said x bar is equal to. At this point, let's try to get star gravity along x-axis. So we said x bar is equal to. Alright, we said x bar is equal to what? X1 A1. What's x1? I have 20 times what's A1? 4,800. I'm done with this one. Plus, I have a plus sign here. What's x2 times A2? x2 is what then? 40 times A2 is what? 3,200 please. Alright. All over A1. What's my A1? 4,800 plus what's A2? A2 is what? 3,200. Alright, let's get value this. If I punch this one together, please give me value this. Value this. This one here. X bar is equal to 20 times 4,800 please. 96 for them. 1,000 plus give me value this one please. This two please. Huh?
128,000.
Huh? Say?
128,000.
Now what is my this?
That's 8,000.
8,000 right?
Yes.
8,000 right? Alright, give me value for this one please. Add this one for me please. What's x bar? X bar becomes. Alright, add on this. Add on this. You said what then?
224,000.
24,000 all over 8,000. Please give me value for S bar. So star gravity along
8.
How about that?
28
millimeter as my center of gravity along x axis. So let's find the center of gravity along y axis, please. Alright, let's get center of gravity along y-axis. We said y bar is equal to summation ya over summation a. That becomes y1 a1 plus y2 a2 all over. Alright, let's get the center of gravity along y-axis. So for y-axis, we said summation ya over summation a. I'm having a y1 a1, y2 a2, a1 a2. Of course, the only thing that does not change here is your area. So my area becomes the same. So I'll have that y1, y2, next up a1, a2. Give me a1 please. A1 is the same as this, 4,800 millimeters squared Get A2. A2 is what? 3,200 millimeter of squared. Finally, let's get Y1, Y2. How do we go about this? For my Y1, observe as section 1 is this. Before I get to section 1, I have moved a distance of what? 40 upwards. So when it comes to your y-axis, I'm considering distance first before the actual section. So for this section 1, before I get section 1, I'll move a distance of what? 40. So that becomes 40 plus after section 1 itself. When I get a table, to get the center of gravity for y-axis, I give that h over 2 is simply the what? Center of gravity for along y-axis. Check the table, I give this area. So to get center of gravity along y-axis for section 1, because my h, what's h here? The height is what? 120. 120. Remember what there? 2. Of course, I'll have 40 plus what there? 60 to give 100 millimeter as my center of gravity along y-axis, please. Next up, for y2, this is y2. Before I get to y2, will I move any distance upward? Nothing is there. This is the ground, right? So that's zero distance. I have 0 plus. Next up, consider your y-axis. Look up. For this section now, what's my height? Of course, height becomes 40. So I'll have 40. Next up, divided by 2. If I divide this, I'll have 20 millimeter. Of course, let's get our center of gravity along y-axis. So I'll have that y bar is equal to, say, y1a1. What's y1? I have 100. 100 times what's a1? That's 4,800. I have this man. Alright, let's proceed here, please. Look up. From here now, I've got to my y1a1 plus, let's get y2a2. Y2 becomes 20 times A2 becomes 3,200. Please help me count, please. All over A1, A2, which is 8,000. Please give value, please. Y bar is equal to, I'll have 4, 8, 1, 2, 3, 4. Next up, plus what is all over 8,000. Please give me numerator, please. Y bar is equal to, Y bar is equal to 12,000, right? All about what then? 8,000. Please give an answer, please. What's Y bar? Y bar? Y bar? 14. 14? 14 what then? Millimeter, right? Is it 14 please? Check, is it 14? What was 28? Yes, 28. Why is 14? Why 14? Why 14? 120. Alright. Let me point this one here. Look up. Point this two, please. I have this.
48,000.
48,000.
Not 48,000.
Okay, 40,000, Abi?
Yes.
Next up, point this guy here. I have this, Abi?
64,000.
Now, add this together. This is correct. This is the same thing.
Yes,
Are you sure? Let me punch. Yes.
112,000.
112 by this, Abi?
Yes.
Divided by 8,000, please.
That one is 480.
Which one?
480,000.
480. This one, Abi? That's the area.
480,000.
This one.
Yes. No, 100 times 4.
This one, Abi?
Yes, it's 480,000.
Let's have it.
Yes.
Alright. Add this one.
That is 544,000.
So this one choose, Abi?
Yes.
5 what then?
444,000.
544,000. Alright. Divide this one, please.
That is 680.
6 what then?
680.
68.
680.
Are you sure?
680.
600 and what then?
80.
80 millimeter. And how much is 680? Why is it not 80? my value for x axis and what the y axis. These are to go about finding center of gravity along